Hello and welcome to this tutorial on collision domains. So by now you've had exposure to Ethernet and the shared bus concept, as well as hubs and CCNA with CD, as well as collisions themselves. Well, it now makes sense to understand what a collision domain is. And this understanding is going to help you better understand and grasp network design and understand how devices connected to a network communicate and the implications of how they communicate. So understand a little bit better what I mean by that when we take a look at the definition. We'll figure out what a collision domain is. And then we're going to go ahead and take a look at these different devices, hubs, bridges, switches, and routers, and see how they define collision domains and how they impact network design. Okay, a collision domain is defined as a group of devices whose frames could collide with other members of the same group. So let's say you have two PCs, and if a frame created by either PC could collide with a frame created by the other PC, then those two PCs, both devices, are considered to be in the same collision domain. So let's take a look at how a hub defines a collision domain. And it's pretty straightforward with hubs because every interface on a hub is in the same collision domain. So all three of these PCs are considered to be in the same collision domain. And we know that with hubs, if a PC sources a frame, it's going to hit the shared bus, and the hub simply repeats it out every connected port. So it's possible for a collision to happen with either one or both of these other two connected devices, and that is a collision domain. If you were to add another hub to this hub, say your network is growing, and this is a hub, then every device on this new hub is also in one collision domain. And since these two hubs are connected to each other, they're both in the same collision domain. So all you've done is you've added more devices to the same collision domain. Okay, so hubs, a single collision domain. Let's take a look at how bridges create and define collision domains. Okay, in this local area network, we have a bridge at the center, and connected to it are two hubs, and then two PCs hang off of each hub. And bridges function differently than hubs. A hub, as we know, just repeats a frame out any connected interface, whereas a bridge is a bit smarter. What it does is when a frame comes in, it takes a look at the destination address of that frame, and it compares it to a list of addresses it knows. And when it finds it, it says, okay, I know the interface that I need to send the frame out in order to get it to its final destination, and it only sends it out that particular interface. It doesn't repeat it out every connected interface. So it's a bit smarter. Bridges live at OSI model layer 2, whereas hubs are at layer 1. And so with that in mind, we know that a bridge creates multiple collision domains. So every interface connected to a bridge is a separate collision domain. So that's one collision domain, and then this interface is a separate collision domain. And so we'll just call that number 2. So a bridge creates multiple collision domains, and every interface on a bridge is a separate collision domain. Let's go ahead and take a look at how switches perform. Okay, in this local area network, we have a switch in the middle, and we've connected 4 PCs to it. And switches are similar to bridges, but they have a lot more features. They're a lot more robust. You can do a lot more with them. However, when it comes to talking about collision domains, they're very similar. A switch will also create multiple collision domains. So, very simply, every device connected to this switch is in a separate collision domain. Every interface of the switch is a separate collision domain. So here we've created 4 separate collision domains. Let's now take a look at how routers perform. Here we just have a router and with 2 interfaces. Everything connected to each interface is a bit irrelevant for our conversation, so we've just used a cloud to represent those network segments. And routers are like switches when it comes to collision domains. So routers create multiple collision domains, and every interface of a router is a separate collision domain. So here we just have two, 1 and 2. So two collision domains created because each interface is its own collision domain. So let's now take a look at a diagram with all the devices put together, and we'll review what we just went over. Okay, here's our overall network, and we'll look at each device in this larger context. So if we didn't have these different devices creating different collision domains, everything would be in one collision domain, just like the hub. So we'll start there, and every interface on the hub is in one collision domain. So if we move on to the switch, we know each of its interfaces creates a separate collision domain. The router, the same thing. And the bridge, the same thing. So we've created 6 different collision domains here. If we didn't have this type of network segmentation, breaking it up into different collision domains, then we would likely have a network with poor performance. Because if you just focus on this hub single collision domain here, every time a packet is sourced, a frame is sourced, it could collide. And if a collision occurs, then they use CSMA CD, and so there's some waiting involved, and then a packet is retransmitted. And we know that there are only a certain number of devices you can permit on there until a threshold is crossed, and then too many collisions happen too often, and it gets saturated. It crosses a threshold of usability, so to speak. So a collision domain enables you to break up your network so that you don't run into these problems, and you're not wasting as much bandwidth, and you overall create a more efficient network. Okay, and that's everything you need to know about collision domains. Let's just take a quick summary of what we've gone over. Okay, so we know what a collision domain is. Devices in a group whose frames can collide with each other. And we know that each device we covered, a hub, a bridge, a switch, and a router, they all define collision domains differently. So they break up networks depending on what kind of device it is. And we touched briefly upon impact on a network by the collision domain. So if you have just one, you're going to have a more or less inefficient network, whereas if you segment your network into many different collision domains, you avoid a lot of the problems that come with it. So there are benefits of network segmentation when it comes to collision domains. Okay, and that's everything you need to know. Thanks for watching.